Okay, so it looks like the question is, how do you get from here to here? What are this logic that allows you to make all these conclusions here? So this first step right here, here's the little trick. If you add and subtract those two terms, and you're really just adding 0, now from the first two terms, you can factor out an a. So from this term, if you factor out an a, you're left with a to the k. And if you factor an a out of this, you're left with minus b to the k. And similarly over here, if you factor out a b to the k, from this first term, you're left with an a. If you factor out a b to the k from this term, you're left with a b. So that's how you get from here to here. They kind of left out that part. Now, here's the hardest part to understand. This factor right here in the first term, they're really separating into a minus b times some polynomial. And to explain that, it might be easiest to start with a specific example. Can you write a to the fifth minus b to the fifth as a minus b times some polynomial? Well, you can figure out what it would be by doing long polynomial division if you wanted to. And here's kind of what that looks like. A minus b divided into a to the fifth minus b to the fifth. I'm not going to go through all these steps, but the point is you start to see a pattern if you do a few of these. The polynomial starts with a to the fourth, that's the k minus 1 right there. And those k's, or that reduced by 1 until you get a to the 0, or 1. And the exponents on b go from b to the 0, b to the first, b to the second, b to the third, b to the fourth. Okay, so there's a pattern there. And here's another one. If you want to do a to the ninth minus b to the ninth, that's a minus b times a to the eighth b to the 0, a to the seventh b, etc. And what happens if you actually distribute this a minus b, you get a to the ninth for the first term, you get minus b to the ninth for the last term, but all the terms in the middle cancel out because you increase the exponent on a by 1, and then you multiply by minus b, and those terms all cancel out. Okay, so this a to the k minus b to the k, that's what they're doing. They're reducing the exponent on a by 1 and increasing the exponent on b by 1 until you get to b to the k minus 1. Okay, so that's what's happening here. We expanded a to the k minus b to the k into a minus b times this corresponding polynomial. And now, each of these terms separated by this plus sign contains the factor a minus b. So it's kind of like factoring by grouping. We're going to factor out the binomial a minus b from each term on either side of the plus sign. That leaves this factor of a right here, and this a to the k minus 1 all the way down to b to the k minus 1 plus b to the k. Now all that's left is to distribute this a times every term in here. That's just going to increase each of the exponents on a by a value of 1. And that's what you end up with over here then. That's after distributing the a and then tacking on this plus b to the k at the end. Okay, I have a feeling this is part of a mathematical induction problem, but hopefully that gives you some clue on how you get from here to here. If you have any questions, post a comment.